Hello, good morning, students. Now, our topic today is gravitation. In this gravitation, first of all, I would like to discuss about the Earth. Say, for example, Earth, the shape of the Earth is generally spherical in nature. Let us say mass of the Earth is capital M and the radius of the Earth is capital R. Say, for example, if a person standing on the surface of the earth, let us say you are standing on the surface of the earth. Generally, what you can say, what is the distance between you and the earth? I am asking the question. So, for that, generally, people say that the answer why, because I am on the surface of the earth, then we can say that distance between me and earth is 0. But actually, that is not the answer. Now, we can say that the distance between you and the earth can generally considered as capital R, which is nothing but the radius of the earth. Generally, the distance always calculated from center to the center. So, the person center to the center of the earth. So, if you neglect this small distance, this is the big distance. That's why you can say that simply the distance between the you and the earth is capital R. Now, when it is on the surface of the earth, some force will be acting on that person. So, according to Newton's law of gravitation, Newton's law of gravitation, he say that force between two bodies, one is body of mass small m and earth mass is capital M. So, the force between these two bodies is directly proportional to product of their masses and inversely proportional to square of the distance between them. So, we neglecting the distance from surface to the center of the man. Therefore, to remove the proportionality, you can get F is equal to G capital M small m by R square. This is the formula for the Newton's law of gravitation. So, where G is called the universal gravitational constant. The value of capital G is generally its value is fixed one, that is 6.67 into 10 power 11. You can write the Newton units for this will be Newton meter square kg power minus 2. So already dimensional formula, we can check the dimensional formula from our previous topic. This is the capital G value, there is a fixed value. Now from this you can get the relation between small g and capital G. So what is the small g means? The acceleration of the body. So the acceleration of the body. So we can say that if the person standing on the surface of the earth, then on him the weight will be acting always downwards. Then you can write that here F is equal to, simply you can write mg. M is mass of the person, G is the acceleration due to gravity. Then equating these two, you will get Gmm by R square is equal to mg. So cancel this small m. Then you will get the relation between small g and capital G is small g is equal to Gm by R square. This is the formula for the relation between small g and capital G. Next will be the question orbital velocity and escape velocity. Two questions I would like to discuss now. First question is orbital velocity. Okay, let us discuss about this orbital velocity. So orbital velocity. So how can you define this orbital velocity? Represented by symbol of V naught. So the definition for the orbital velocity is the horizontal velocity of an object to revolve around the planet in a circular orbit is called the orbital velocity. Simple. So you can say the definition is horizontal velocity of an object to revolve around the planet in a circular orbit. In a circular orbit. is called orbital velocity. That's all. Now, how can you get the expression for the orbital velocity? Here, let us say this is Earth, whose radius is, as you know, that capital R, and the mass of the Earth is capital M. Let us say the orbits will be around the Earth. Let us say this is a orbit which is around the Earth in the circular manner, which is at a height h from the surface of the Earth. Here is a, let us say this is an object whose mass is small m, which is at a height h. Okay, now from the surface of the Earth. So we can get what is the total height. You can observe here. Total height generally you have to consider from the center of the Earth. That's why we can say that r plus h, you can say. Now there must be a gravitational force between these two. Why? Because it is rotating in the circular manner, means it will possess centripetal force also. So for this expression, you better to write the two lines here. That is, to get the expression, consider a satellite of mass small m revolving around the Earth at a height h. Let capital M is mass of Earth and capital R is radius of Earth. Now you can say that the gravitational force between these two. So according to Newton's law of gravitation, the gravitational force between B by W, Earth and satellite, is, as you know the formula, F is equal to G capital M small m by R square. This is the formula for the gravitational force. So it possesses some centripetal force also. Why? Because it is in the circular manner. So the centripetal force due to the Earth, F centripetal, generally what is the formula for this? M is square by R. So here you better to remember that the distance between man and the Earth is R plus H. That means in place of R you can write R plus H whole square. Okay now? Now what is the centripetal force acting here? Same formula, mv square in the sense v naught square orbital velocity by distance. Distance between these two is, as usual, r plus h. Now equating these two, what you will get? Equating these two. So at equilibrium you can say that F gravitational is equal to F centripetal force. So what you will get? Gmm by r plus h whole square is equal to mv naught square by r plus h. One small m cancelled, one r plus h cancelled. What you will get? V naught square is equal to gm by r plus h. Simply V naught is equal to under root of gm by r plus h. If satellite is near to the surface of the Earth, that means h will be very less than smaller. Simply neglect the h value. What you will get? Finally you will get V naught is equal to under root of gm by r. But from the above relation I know that small g is equal to gm by r square. This is the relation. From that I can write g is equal to gm by r square, or simply gr is equal to gm by r. Now simply substituting here, you will get V naught is equal to under root of gr. This is the formula for the orbital velocity. So in this way you can derive the orbital velocity formula.